In this question, we're told that the points A, O, and B lie on a straight horizontal track, just like was shown in the diagram. A is 20 meters from O, and B is on the other side of O at a distance of x meters. At time t equals 0, so at the beginning of our observation, a particle P starts from rest at the origin and moves towards B with uniform acceleration of 3 meters per second squared. At the same instant, at the exact same time, another particle Q, which is at the point A, is moving with a velocity of 3 meters per second in the direction of the origin with uniform acceleration of 4 meters per second squared in the same direction. Given that Q collides with P at B, find the value of X. Well, there's a lot of information here, but we know we have two particles and they start their journeys at the same time. Let's collect SUVAT variables for each of them. P starts from the origin and travels towards B, so we know its displacement is x. It started from rest, so we know its initial velocity is 0. Final velocity we're unsure of. Acceleration we're told is 3, and the time we're going to refer to as t. For Q, similar situation, but it's traveling further. It's traveling 20 meters further. The displacement is x plus 20. The initial velocity this time around is 3. We don't know the final velocity. We know the acceleration was more. It was 4 meters per second squared. And once again, time equals t. We're told they collide, which means they're in the same place at the same time. So let's find out how far P has to travel and how far Q has to travel. And we're going to put that into a formula that uses the variables we have. S equals ut plus half at squared. We're going to do that for both of these particles. For P, I get x equals 0 plus 3 over 2 t squared. For Q, we get x plus 20 equals 3t plus 2t squared. Well, on the left, I have an expression for x, and on the right, I can substitute that in. So, swapping x for 3 over 2 t squared, we get a new equation, which is actually a quadratic. We can tidy this up, we can rearrange, and I get 0 equals a half t squared plus 3t minus 20. I'm going to multiply by 2 to get rid of the fraction, and this is a quadratic I should be able to factorize by hand. I don't need a calculator, I can just factorize this by recognizing 10 and negative 4. That gives solutions of negative 10 or t equals 4. Negative 10 would not make any sense for the time taken, so we're going to go with t equals 4. Well, if t equals 4, what is the value of x? Particle P would have been traveling for 4 seconds, and we know its displacement can be found by using the expression 3 over 2 t squared. Let's substitute in our 4. 3 over 2 multiplied by 16, that gets 24 meters. The value of x is 24 meters. Particle P has traveled 24 meters. Particle Q has traveled 44 meters. And I'll leave you to check that you're correct by substituting t equals 4 into the displacement equation for Q, and we should get the anticipated 44 meters.